Dear viewers, dear biology lovers, I welcome you yet to another episode of our biology homeostasis series. Today we are going to look at yet another way another thing that we need to regulate in our bodies, and this is none other than the regulation of sodium ions. In our bodies we have got sodium ions, and these sodium ions help us in very many ways, one of which you know very well sodium ions are used in nervous coordination. So likewise, like we have been seeing the regulation of glucose, regulation of calcium ions and so on, likewise also these sodium ions must be regulated within their bodies. So we are going to learn how is the body able to do that work. Now we are going to begin with a scenario where the sodium ions in the body are very low. What does the body do to bring them, to raise them to higher levels? Because we need them, they are very key. So when sodium ions are low in the body, low sodium ions in the body will bring about what we call low blood pressure and low blood volume. You might be asking yourself, how? Yeah, you know very well that if you have got a blood vessel, for example, have a blood vessel, and inside this blood, inside this blood vessel, we have got very many sodium ions. These sodium ions are important in such a way that they enable osmotic inflow of water from the cells into the blood. So it means when ions are somehow much in the blood vessel, more water is withdrawn from the cells by osmosis into the blood vessel, which will increase the volume in the blood vessel, and at the same time, the increase in volume at the same time increases also the pressure in blood. So it means when sodium ions are low, we have the reverse. We have less inflow of water into the blood vessels, and therefore that one brings about low blood pressure and at the same time low blood volume. So that is it. That's how it comes about. So because of low sodium ions, we have got low blood pressure and low blood volume. Why? Because there is no osmotic inflow of water from the adjacent cells. So it is these two, the low blood pressure and the low blood volume, that are going to stimulate. So these two are the ones which are going to stimulate. So these two conditions are going to act as stimulus, which are going to stimulate a group of cells. This group of cells are found in a structure within our body that we are calling Juxtaglomerular complex. This juxtaglomerular complex is a group of cells. This is a group of cells. It is a group of cells, secretory cells. Sorry. This is a group of secretory cells found between the distal convoluted tubule and the afferent arteriole. For those ones who know the structure of the kidney, I know very well that you know what you mean by when you say distal convoluted tubule and afferent arteriole. For example, if this is our nephron, those ones who don't know the nephron, this nephron is found in the in the kidney. So we have got the afferent vessel, or afferent artery is the blood vessel which brings blood into this structure we are calling the glomerulus. And then our distal convoluted tubule is this tubule which is found in this area. So all the cells which are found within this area here, the group of cells which are found within this area here, is what we are calling, is what is found in the juxtaglomerular complex. I hope that is very clear. So we are saying that the low blood pressure and low blood volume stimulate this complex, or this group of secretory cells. And since they are secretory cells, it means they will end up secreting. So once this glomerular complex is stimulated, what will happen is that it will, once it is stimulated, it will, these cells are going to secrete. They are going to end up secreting. After all, we have said that it is a group of secretory cells. So these cells are going to secrete, they are going to secrete an enzyme. They are going to secrete an enzyme, and this enzyme is none other than renin. I want you to take note. This is renin, not the other renin in digestion. This is renin. The renin in digestion has double N, but this renin here has single N. So these cells, once they are stimulated, they secrete this enzyme renin. Which enzyme renin? You know, enzymes usually do the work of catalyzing. So once this enzyme renin has been secreted by these cells in this area, this enzyme catalyzes a reaction. And what is that reaction? So this enzyme will catalyze. That enzyme will catalyze the conversion. They will catalyze the conversion of a plasma protein. So in our body we have got a plasma protein, and in this particular case our plasma protein is called the angiotensinogen. So this is a plasma. This one is a plasma protein. This is a plasma protein. It's a plasma protein, and once it is now we are saying the renin will catalyze the conversion of angiotensinogen. So this is a plasma protein within the body, or within the plasma. So once this one is converted, it is going to be converted into something, and this something is, you know, angiotensinogen. So it's going to be converted into what we call angiotensin. And this angiotensin is a hormone. It is a hormone. So the plasma protein which is inactive and is called angiotensinogen, by the way, this is inactive. So it is converted into an active hormone. Which active hormone we are calling angiotensin. Now it is this active hormone which is called angiotensin that is going to continue moving and proceed to what we call the adrenal glands. In the adrenal glands, we have got what we call the adrenal cortex, and we have got what we call the adrenal medulla. But in this particular case, this hormone is going to go specifically to the adrenal glands, and to be more specific, in the adrenal cortex. So this hormone moves. In blood. After moving in blood, and it reaches in the adrenal glands. When it reaches in the adrenal glands, it stimulates the adrenal cortex. It stimulates the adrenal cortex of the adrenal glands. Yeah, and I'm very sure you know very well hormones which are produced by the adrenal cortex. So in this particular case, this adrenal cortex, once it is stimulated by this hormone which we have called angiotensin, the adrenal cortex are going to secrete they are going to secrete a hormone, which hormone we call aldosterone. Hormone which we call aldosterone. Now, let me put it in different things because that hormone is very important. That hormone is very important. We are calling it aldosterone. Aldosterone. So, it is this aldosterone which is going to help us in reducing, in increasing the sodium ions which were very low back to a normal level, which is going to enable the body metabolic process like coordination to proceed normally. And we are going to see how it does that. But before we can go to how aldosterone helps us in reducing, I also want to take you through this small thing also. That apart from us having the low blood pressure and low blood volume stimulating the juxtaglomerular complex, we can have this glomerular complex also become stimulated through another pathway. And what is this other pathway? This other pathway is here, that the sodium ions which are low in blood can at the same time, allow me rub this line and use this end. The low sodium ions in the body can at the same time be detected. All these stimulus of low sodium ions can at the same time be detected by the hypothalamus. So the blood which is passing through the hypothalamus can when it is having low sodium ions, the receptors within the hypothalamus can detect it. So the sodium ions can at the same time be detected by the hypothalamus. Let me do like this. The sodium ions can at the same time, the low sodium ions can be detected by the hypothalamus. Yeah, for those of you who are watching me and maybe you're not much into the biology, the hypothalamus is part of the brain. It is another part in the brain. So that part of the brain can detect that in the body we now have low sodium ions. And once it has detected that, this hypothalamus controls another part of the brain. And that part of the brain is none other than the pituitary gland. So we have got the pituitary gland next here. Pituitary gland. So the hypothalamus, after detecting, it does what? It stimulates the pituitary gland. Now this pituitary gland, actually to be more specific, the anterior part of the pituitary gland secretes another hormone. So this pituitary gland is also found in the brain. So this pituitary gland, once this has been stimulated by the impulses which have come from the hypothalamus, can at the same time also produce another hormone. So what is that hormone which is produced by the pituitary gland after it has been stimulated? That hormone is none other than, check here very well, is none other than ACTH. What is ACTH? ACTH in full is the adrenocorticotropic hormone. That is the ACTH. After we have produced ACTH, this ACTH now moves in blood from the brain. Remember, I've told you these two are found in the brain. So this ACTH moves from the brain and it comes and also reaches where? It comes and reaches into our juxtaglomerular complex. And then the process continues. That now the juxtaglomerular complex, after it has been stimulated by the impulses which have come from ACTH, then these impulses stimulate. Now let me write here that now the impulses which have come, this hormone which is the ACTH, comes and stimulates the juxtaglomerular complex, and then the cycle repeats. juxtaglomerular complex. Then this complex secretes an enzyme which is called renin, which enzyme catalyzes the conversion of a plasma protein which is inactive, which we have called angiotensinogen, into an active hormone which we have called angiotensin. After we have got angiotensin, the angiotensin now stimulates the adrenal glands. Specifically, stimulates the adrenal cortex of the adrenal glands to secrete a hormone which is called aldosterone. So, after we have produced aldosterone, what does aldosterone do? Remember, our glucose level are low. So, after we have gotten aldosterone, this is what aldosterone does. So, aldosterone, we can say, stimulates the following. What is that? So, aldosterone, once it is secreted, it does the following. One, it stimulates an increased absorption of sodium ions from the what? From the gut. Remember, the foods we eat also have these ions. So it means once we have low sodium ions in our body, then more sodium ions are absorbed from the gut, so that we can retain back our normal sodium ion levels. At the same time, apart from that, what does aldosterone do? Aldosterone, once it is secreted, it also stimulates. It also brings about or stimulates a decrease in the concentration of sodium ions in the sweat. You know, when you are sweating, some of you bear me witness. If you have ever tested on your sweat is somehow sweet, somehow salty. So it means once remember. So why is it tasting like that? Because it has got these ions, the sodium ions, the quiet ions, and so on. So what happens is that once aldosterone is produced, it decreases. It ensures that we have less of the sodium ions in that sweat. Remember, we don't need to lose the sodium ions. Why? Because we have got low amount in our bodies. Then what else? Likewise, apart from the sweat, we also lose sodium ions, by the way, through our urine. When you go to urinate, your urine also has got these ions. So what do? What happens is that once aldosterone, remember, we have less of the sodium ions in our body. So once aldosterone has been produced, it ensures that it stimulates an increased reabsorption of the sodium ions in the kidney nephron. Remember, it is the kidney. Within the kidney, that's where we form urine. That's where urine is formed. And once it is being formed, one of the components of urine is sodium ions. So once this aldosterone has been produced, it ensures that sodium ion is not lost in urine, but instead of it being lost in urine, it is totally reabsorbed. We are going to learn more on how urine is formed in our next episodes. As for those ones who are following me, we are also going to learn on how urine is formed, and we shall see more details on how these sodium ions are reabsorbed. It's something very interesting. You don't need to miss that. So, in case sodium ions are low, then more of them are reabsorbed within. In other words, the body takes them back instead of losing them in the urine. Now, guess what? After all these things have happened, you are very sure that the sodium ions which were previously low will automatically somehow increase and bring and we shall retain our normal sodium ions. We shall retain back our normal sodium ions in our bodies. Isn't that one very interesting? You can imagine what will happen, all these ones are happening in your body when you don't know. Now, after you have understood this, I'm very sure that you can now easily tell what will happen if the sodium ions are in excess in our bodies. When sodium ions are in excess in our bodies, we need to also lower them. Why? Because if we don't, they will end up making us to become dehydrated. Because why? Because our cells will be losing water by osmosis. Let me give you a small illustration here. If this is the blood vessel, and we have got a lot of sodium ions in our body, in this blood. So what will happen is that these adjacent cells in this which are adjacent to these blood capillaries will end up losing their water by osmosis. Remember, water is going to tend to come from the cells into the blood vessel so as dilute the too much sodium ion. So that one might cause you to become dehydrated. So they are needed, but they don't need to be too much because of that problem. So after you have understood how the body regulates when sodium ions are low, I'm sure that you can now follow with me. You can actually even easily quickly tell what will happen when sodium ions are above the normal. How? So it means that when sodium ions are very high in the body, so it means that there will be an increase. There will be an increase in blood volume and pressure. How? It's what I'm just from explaining. That when sodium ions are too much, cells tend to lose water into. There will be osmotic inflow of water from the cells into the blood, so as to dilute that too much ions which are in the blood vessel. So in that, when water comes into the blood vessel, it means the blood vessel will be filled with too much. That will be increase in volume, and also the pressure will be too much. So this increase in blood pressure, it means it will stimulate. It means this one will stimulate. It means this one will stimulate. It will stimulate the juxtaglomerular complex. Can follow me now? But in this case, this juxtaglomerular complex is going to be stimulated in such a way that it will secrete less of our enzyme, less of the enzyme, which enzyme we have called the renin. So if less of renin has been secreted, it means we shall end up having this one will bring about a low conversion of angiotensinogen into angiotensin. So we shall have a lower conversion of this. It means we are going to end up having less of the angiotensin. So if we have less of angiotensin, it means that this less of angiotensin will not stimulate the adrenal cortex enough to produce enough aldosterone, meaning that at the end of the day we shall end up having less or even no aldosterone produced. Why? Because we have produced less angiotensin, which will not be enough to stimulate the adrenal cortex to produce enough of the aldosterone, implying that we shall have less aldosterone. If we have less aldosterone, it means that instead of having increased absorption, our sodium ions are very high. We shall have a decrease in absorption of sodium ions from the gut. Instead of having a decrease in concentration of sodium ions in the sweat, we have excess of sodium ions. So instead of having a decrease, we shall have an increase in concentration of sodium ions in sweat, so that we can lose the excess sweat. Likewise, instead of having an increased reabsorption of the nephron in the kidney, an increased reabsorption of sodium ions in the kidney nephron, we are going to have a situation whereby we shall have a decreased reabsorption of sodium ions in the kidney nephron, so that the excess sodium ions can be lost in urine, implying that if you have excess sodium ions in your body, you will urinate, you will give out urine which also has a lot. Why? Because there will be a decreased reabsorption of the sodium ions in the kidney nephron, so that the excess can be lost in urine. In that way, the body would have been able to ensure that the sodium ions become or remain regulated, so that the body metabolism can continue normally, and in that way the body will be able to continue without any interruption. So in case you are viewing this video for the very first time, and you know you have learned something, and you don't need to let your friend also miss out. Inform a friend to subscribe, so that you can enjoy more of this series. Thank you very much, and please make sure you subscribe. Meet you in the next episode of still the homeostasis series, and the next video will be about regulation of calcium ions and even very many other substances. Thank you very much. May God bless you.